Given the complex number z is equal to a plus bi, find, first of all, z plus z conjugate. So this is a plus bi minus, a minus bi. So we've got 2a, and then the bi's cancel, so we're just left with 2a. So no matter what z is, when you add it to its conjugate, you're always going to get 2 times the real part. And notice this is just a real number. There is no imaginary part here. This is completely real. Z minus z conjugate is going to be a plus bi, take away a minus bi. A take away a cancels out. B take negative bi is going to be 2bi. So we get 2 lots of the imaginary part this time. And this is a purely imaginary number, not complex, there's no real part. Z times z conjugate. So this is a plus bi times a minus bi. Now this is a difference of 2 squares in itself. So we know that this is going to expand to a squared minus bi squared, which is b squared I squared. But I squared is negative 1. So this simplifies to a squared plus b squared. Now this result is what's sometimes known as the sum of 2 squares, because it means we can actually factorize the sum of 2 squares. It just means we need to use a complex number. We have something like a squared plus b squared. We can factorize it into a plus bi times a minus bi. But again, notice that the answer here is real. A squared plus b squared is real because a and b are both real numbers. So the result we get when we multiply a number by its conjugate is a real number. Z conjugate. So that is z conjugate is going to be a minus bi. And then the conjugate of that is going to be a plus bi, which is just z. So the conjugate of the conjugate just takes you back to the original number. The conjugate squared is a minus bi, because that's the conjugate squared. So a squared, and then expanding this, we're going to get minus 2abi plus b squared I squared, which is a squared. Now I squared is minus 1, so this is going to become minus b squared minus 2abi. Now I rewrote it in this order just because this is the real part and this is the imaginary part. Now what about z squared and then conjugate? So this is the other way around. So first of all, this time we need to work out what z squared is. That is a plus bi squared, and then take the conjugate of that. So inside the brackets, we're going to get a squared plus 2abi plus b squared I squared. I'm going to take the conjugate of that in a minute. But I squared is negative 1, so this becomes a squared minus b squared plus 2abi. Again, rewriting it so it's the real parts and then the imaginary parts. And then taking the conjugate of that means the imaginary part, which is this part, becomes negative. So we get that result there. And we notice that these two are equal. So what we've actually shown here is that these two are equal. It doesn't matter whether we square the complex number and then take the conjugate, or take the conjugate and then square it. Now that's useful because sometimes one way or the other might be an easier approach. And it's good to be able to switch between those, and we now know that that's true because we know whichever way we do it, we get the same result.